And here's the second part of Descartes' real signs. The number of negative real roots of the polynomial p of x equals 0 equals the number of variation of signs or sign changes of p of negative x, or is fewer than this number by an even integer. So what does it mean when we say p of negative x? Well, here's p of x. Here's an example. X to the 8th plus 2x to the 7th, etc. And if we want to evaluate p of negative x, then every time I see an x, I would put a negative x. All right, so every time I see an x, I put a negative x, and then I work that out. Now remember, if you raise a negative sign to an even power, every two negative signs, when they're multiplied times each other, will make a positive sign. A negative times a negative is a positive. So if we have an even number of them, that's going to be a positive. All right, so in essence, this really doesn't change. If I have an odd power and I raise a negative number to an odd power, it becomes negative. In that case, it does change. Well, you'll see just a second. So we have to keep that in mind. So let's take a look at this one at a time. And again, a negative x to the 8th is just going to be the same thing as x to the 8th, because that's going to be a positive. So it's just going to be, because remember, a negative to an even power is positive, so it's just going to be x to the 8th. So that hasn't really changed signs. Now, if I raise a negative to an odd power, it becomes negative, but a negative times a positive is a negative, so this does change signs. All right. Now, if I raise a negative to an even power, it becomes positive, so this is just a positive times a negative is a negative. So it doesn't really change signs, does it? And if I raise this negative to an odd power, it becomes a negative. A negative to a fifth is a negative, so this is a negative x to the 5th, and a negative times a positive is a negative. So in essence, this does change signs. And we'll see a pattern here, and that's going to lead to a little shortcut we can use. A negative to the 4th power is a positive, so this just becomes a positive x to the 4th times negative 2 is just negative 2 x to the 4th. And a negative to an odd power is a negative, and a negative times a negative is a positive, x to the 3rd. And a negative to an even power is a positive, so a positive times a negative is a positive. I'm sorry, a positive times a negative is a negative, excuse me. And then negative x is just a negative x times a positive is a negative x. So that's how we would put the negative x in and show that we have this. Now notice that my even powers didn't change signs, but my odd powers change signs. Even powers stay the same. The odd powers change signs. Even powers stay the same. The odd powers change signs. Even powers stay the same. The odd powers, because that's the first powers, change signs. So that's just a little shortcut you can use. When you're evaluating p of x, odd powers change signs. Even powers do not change signs, so you don't really have to do the substitution. I want you to see it at least once so you understand how the theorem works, or how the rule works, how the rule works. But once you notice this, you can just apply this little shortcut because it always works. So here's an example, and we can do this a little quicker. So p of negative x would be, so since this is odd, it will change signs, so that's going to be negative x to the 9th. This stays the same because it's even, so it's going to be negative x to the 8th. This changes because this is odd, so it's going to be negative x to the 7th. This stays the same because it's even, so it's going to be negative x to the 6th. This changes because this is odd, so it's going to be negative x to the 5th. This stays the same because this is even. This stays the same because that's even, so it's going to be negative 2x to the 4th. This changes because this is odd, so it's going to be negative x to the 3rd. This stays the same because this is even, so it's going to be negative x squared, and I got plus 1. So how many sign changes did we have? Just one. Oh, I'm sorry I didn't go back and actually finish this one up. Excuse me. I was so interested in the sign changes. How many sign changes do we have back up here in this example? Positive and negative, 1. No. 1 here. Negative to positive, positive to negative. So how many sign changes did we have here altogether? 1, 2, 3. So we can say there are 3, or 2 less than 3 is 1, negative. Excuse me, I didn't finish that up because I was so interested in noticing this little shortcut, all right? So we did this a long way by substituting in, and we had 3 sign changes. Now if we look over here, using our shortcut, we can write our p of negative x here, and you want to write p of negative x, so keep that straight. But how many sign changes do you have? Just happen to have 1. So we can say there is 1 negative real root. And that's a good result because that's going to tell us that one of our negative possibilities will be a root. Oops, excuse me. Goes down a little bit. Okay, so we have just 1 sign change, so we have 1 negative real root. If we had 4 sign changes, it'd be that we'd have 4, 2, or 0. So it's always 2 less than what we get by our sign changes. Okay, here's one more. So we write p of negative x. And this is even, so it doesn't change, so it's just x to the 10th. This is odd, so it does change, so that's going to be negative x to the 9th. This is even, so this doesn't change, that's even, doesn't change, so it's going to be positive x to the 8th. This is odd, so this changes, so it's going to be negative x to the 7th. This is even, so that stays the same. X to the 6th. This is odd, so that changes. This is even, so that stays the same. This is odd, so that changes. This is even, that stays the same. And this is odd because this is first power, so that changes. All right, so how many sign changes do we have here? Well, this is understood to be positive, so I got 1, 2, 3, 4, 5, 6, 7, 8, 9 sign changes. I'm going to double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can say there are 9, or what's 2 less than 9? 7, or 2 less than 7, or they say an even integer, so it could be 4 less than 9. 5, or 6 less than 9 would be 3, or just keep subtracting 2, 1, negative real roots. Okay. So a little shortcut makes it a lot easier to do these. Okay. So I hope that makes sense.